This is part 2 of section 6.2. We have been factoring trinomials. We've been talking so far about ones that had a 1 in front of our square term, not another number. But now we need to talk about what to do if there is a number in front. I want to be clear, there are a couple of ways to get this done. If you learned what is basically guess and check, or what some teachers call reverse FOIL, and you are good at it, by all means continue to use it. What I'm about to show you is a method that maybe uses a little bit more paper, but usually is faster. Also, this method, if your answer happens to be prime, you're going to be very confident that it's prime, instead of maybe wondering if there's something you forgot to guess and check, okay? Now, our first step in any factoring is to factor out a GCF if we have one. Now, we really have to worry about that now because we have coefficients in front of our z squared, okay? So I'm looking for anything that will factor out of all of this, and if I just compare these two, the only thing that will go into a 5 is a 1 or a 5, and we're ignoring the 1 possibility. So, but a 5 does not go into 42, nor does it go into 27. So there's no GCF here. Okay. So what do we do when we have a number like this? What we want to do is going to be very similar to what we did here. We're still going to be looking for two numbers that multiply to something and that add to something else. Now, the way we figure out what we want to multiply to is you take these two numbers and you multiply them together, which gives you 27 times negative 5 would be negative 135. So all of a sudden we start dealing with bigger numbers, okay? But then what we want them to add to, we do the same way, okay? Now technically, this works with this type as well. We're looking for things up here that multiply to a negative 18, and if you take that 1 times a negative 18, you're going to get that, okay? So these are special cases of this. All right, so this is what I was talking about when we start dealing with bigger numbers, okay? I'm going to list things that multiply to 135. We'll deal with the sign in a minute, okay? So things that multiply to 135. 1 and 135. And then 2 will not work. Does 3 work? Yes. 3 and 45. And then I can keep going. I'm using my calculator here. What I've done is I've took 135 and put it in memory. And the way you do that is if you take 135, you hit this STO button right here. It means store. And then your variable button is just above that. If I hit X and then hit enter, now every time I hit X, it's going to do 135. So when I'm checking to see if it divides, I use this a lot. And basically I'll do, okay, X divided by 4. That got a decimal, that didn't work. X divided by 5, 27. So 5 times 27. Okay, does 6 work? No. 7? No. 8? No. 9? Yes. 9 and 15. 10 won't work. 11 won't work. And then 12. See, once you tried 12, you went back to 11. This is kind of where you're going to wrap around. Once you do the division and you get a number smaller than what you're dividing by, you've listed them all. I could try 12, I could try 13, I could try 14, but the next one that's going to work is a 15. So I have them all listed down. All right, so I'm multiplying to a negative number. That means one of these is negative. I'm adding to a positive number, so that means the smaller number is going to be negative. What can I do to get a 42? Well, right here, negative 3 and 45. That's what works. Okay. Now, it would be really, really nice if I could just go directly to my answer, if I could do z minus 3, z plus 45, but that doesn't work here. What we're going to do instead is we're going to rewrite this value using these two numbers. Okay, now for reasons that are going to become clear in a minute, if you have a negative and a positive, you really want to write down the negative one first. Not because it's wrong the other way, but because it's going to make your life easier if you do. So I'm going to recopy this 27z squared. Instead of writing positive 42z, I'm going to write negative 3z plus 45z, and then bring down the minus 5. You see here that if I combine these, if I combine like terms here, I'm right back to 42z. So this is the same value as this, it's just in a different form. Now why would we do this? It looks like we made it more complicated, and kind of in a way we did. But what we found actually is the only combination of values that will make factoring by grouping work. Okay, so we've changed a problem that was a trinomial into a factoring by grouping problem, and we know how to do that. The first thing we need in factoring by grouping is a plus sign in the middle, and that's why I suggest you write the negative first, because if you write the negative first and the positive second, you're already going to have that plus sign there. So since we have that, we group our first group together and our second group together. From our first group, I can factor out a 3 and a z, and that gives me 9z minus 1. Plus, remember that plus sign is that plus sign. From this group, I can factor out a 5, and that leaves 9z minus 1. And if we've done this correctly, these two things should match, and you write that down once, 9z minus 1, and then you make a set of parentheses out of what you have left, 3z plus 5. And of course, this is the same thing as 3z plus 5 times 9z minus 1. Okay, so let's try this one. This one has an extra variable in it as well. But the good news is that when you're doing one like this with a number in front and you have to use factoring by grouping, the variables take care of themselves. So you don't even really have to remember to deal with it. Okay, the first thing we do is we look for a least common denominator. Not at least common denominator, or greatest common factor. Sorry, misspoke. Looking at the variables, here's a c, here's a d, so I'm not going to be able to factor out a variable. If I look at the 14 and the 6, I can maybe factor out a 2, but not with the 17. In fact, 17 is prime, so unless these are divisible by 17, there's not going to be a GCF. Okay, and there's not here. Okay, so now we pretty much ignore our variables, and we're going to find what we multiply to and what we add to the same way. I'm going to take this 14 and times the negative 6. So I'm looking for two numbers that multiply to whatever 14 times negative 6 is, and that is negative 84. Okay, so I'm going, and then I want them to add to negative 17. All right, I'm going to list things that multiply to 84. I have 1 and 84, 2 and 42, and then 3 and 28, 4 and 21, and I think that's going to work. You know, I kept listing things up here. That's because I have a tendency to get in a zone and don't really pay attention. But you can always stop when you see the one that's going to work. And if I look right here, if I do 4 minus 21, I do get the negative 17. These multiply to a negative 84, so these are the two values I'm going to use. We rewrite the first one, 4c squared. I'm going to write my minus 1 first because it's going to make factoring by grouping easier. So minus 21, use the same variables as you have up here, plus 4cd, and then minus 6d squared. And again, since we had a negative and a positive, and we put the positive here, we don't have to worry about anything. We can just group. And from our first grouping, we can factor out a 7c, and that leaves 2c minus 3d, plus, from this grouping, I can factor out a 2 and a d, and that leaves 2c minus 3d. And these two are the same, which is good. So we write that down once. 2c minus 3d times 7c plus 2d. And that would be your answer. Okay, last problem in this section. I want to factor negative 12a squared minus 10a plus 42. Okay, one of the things I said earlier is that this is always easier if your first number is positive. So I look at this and I know I want to factor out at least a negative 1. But is there anything else I could factor out? Well, all of these numbers are even, and that means I can factor out a 2. So since I want that first number to be positive and I can factor out a 2, I'm going to factor out a negative 2. That will give me 6a squared plus 5a minus 21. I double check this to see if there's anything else I can factor out, and there's not. Okay, now this 2 becomes a traveler. We cannot lose it, but we don't have to worry about it anymore. Now we're going to be looking strictly at this and trying to factor this as much as possible. So I'm looking for two numbers that multiply to 6 times negative 21 is negative 126. And I want them to add to a 5. Okay. So I start listing things that multiply to a negative 126, or just 126 at all. And that would be 1 and 126, 2 and 63, 3 and 42, 6 and 21, 7 and 18, and then 9 and 14, and I think that's all. Now, if I want to multiply to a negative, then I have one of them that's negative, one of them that's positive. I'm supposed to add to a positive number. That means the left-hand side, my smaller numbers, will be the negative ones. So I'm looking for things that are 5 apart, and that would be right here. If I make that a negative 9 and a positive 14, they multiply to a negative 126. They add to a positive 5. Okay, so over here, don't forget to keep that negative 2. Okay, I'm going to have parentheses inside parentheses and brackets and everything here, so be really careful with this. I have 6a squared minus 9a plus 14a minus 21. Okay, now I have the plus sign in the middle, so we're going to add our grouping symbols. Okay, now we still have this negative 2, and from this grouping we can factor out a 3 and an a, and that would leave 2a minus 3 plus, remember that's that same plus sign, 14a minus 21, we can factor out a 7. That leaves 2a minus 3. So these two are the same. Don't lose your negative 2. And then I have the same thing here and here, so I write that down once. And then I make a set of parentheses out of what I have left, which is 3a plus 7.